right, guys. Hey, thanks for joining me this evening. We're going to have a little fun with, can you build organic matter in a straight blade vertical till situation? The straight blade is an important part of this question. So for that answer, I'm going to say yes, you can. If it's a curved blade or any more aggressive tillage, I'm going to say no, you can't. If you're seeing root balls, you're losing organic matter. Simple. Plain and simple. End of story. Thank you. Have a good night. Thanks for watching. Of course, I've never made a video that short, guys. Come on now. But no, what's happening in the natural system? So let's back up a little bit here first. Everybody says, oh, look at, you see these guys growing this 6 foot tall biomass, and they're crimping it down. And they're like, look at all the organic matter we're going to add. They're going to add 1% of all that residue is going to make it to organic matter. Now, compared to a soybean field, there's a tremendous gain. A soybean field, even in a no-till situation, is almost negligible. You throw in full tillage in a soybean rotation, you're going backwards. So, how Mother Nature intended it is she builds this beautiful, beautiful system of life. Big bugs come up, they eat the residue, they take it back down. When they come back up, they poop again, they excrete just this wonderfully rich new soil. But the whole point of the residue is to give us protection on that soil. That, if you look at the woods left alone, how Mother Nature intended, all that residue is going to be up there. It's going to stop compaction from animals and from rain and weather events. We're going to get water infiltration, temperature control. We're tilling to warm and dry the soil, but we're also exposing it to just being cooked. And then, of course, our big ones are their water and wind erosion. They're kind of huge. So this system's going to, our roots are where we're going to build the organic matter. The life of bacteria and fungi. The roots are exuding them acids and sugars, and the bugs and all the micro life is growing and living and dying and reproducing, and that life cycle is how we're going to build the organic matter. Chemically, that stock versus these roots are very different. How the soil utilizes them is different. It's not the same. It's only the same as if you do full tillage and you pop that root out of the ground. Now it's just a carbon. It dries out. It becomes residue. So we just back to here. When we do the vertical till, we're going to mix in. There's our vertical till machine. Your 4 blades, our axle shaft, and all our residue mixed in that top couple inches. So what's happening is we open that ground up. Like CRP is a great example of opening that ground up with tillage. You get oxygen floods into that soil. And for the first couple of years, you get this wonderful yield out of CRP on a tillage program, and then it drops down. That's because when you open that soil, you introduce the oxygen, you awaken different bugs. You've got some scavengers going on. You killed this guy. These people, you just sent a tornado through their home. Yep, there's a lot of food for them to eat, but everything's in chaos. You've killed their population. They're going to be trying to reestablish a habitat and be working on population. What you've got going here is you've opened up scavengers. So now that oxygen's hitting all that organic matter that was protected in the soil. Now it's oxidizing. Now these scavenger bugs come in and they break it down very quickly. With the shallow vertical, there is some roots in place. So there's a tiny bit of organic matter. Let's say it's a net zero, it's at least maintaining. But you've still exposed your soil to the wind and water erosion. You've still destroyed that couple inches of life and structure. These guys, 15 to 20% of what's in organic matter is the hyphae and the polysaccharides or whatever that these guys are giving off that helps make them soil aggregates. That's building organic matter. So here you're not even, but in this zone, if you've destroyed that, what happens to this soil come middle of June? It's super hot. It's super hot. Water can't infiltrate. You get water ponding. You spread your nitrogen. Then you get your denitrification because you got a bunch of bacteria that can't get any oxygen. So it's just going to eat the oxygen out of the nitrogen. And there goes all your nitrogen or your money. So that's kind of what happens here. The number side of it is kind of funny when you think about it. At a 1% conversion rate, 1%, we're using corn. We're using corn because that's the popular one to vertical till behind. So if we use corn, in an acre we got 43,560 square feet. At 1 inch, 0.083, divide by 27 to get 134 cubic yards of soil in the top inch per acre. Remember, when you do soil tests, you do 6 inches, but let's just do 1 inch just for some fun. Take that 134 yards, 2,000 pounds a yard to get 1% is 2,680 pounds needed to move 1% in that top inch. It'd be a lot more, it'd be 6 times that for the top 6 inches, obviously. Let's give corn 10,000 pounds of residue. That's a massive amount of residue, but let's just have some fun. We give it 10,000 pounds at a 1% conversion rate. 1% of 10,000 is 100 pounds. 100 pounds out of all that residue is going to make it to organic matter in a no-till situation. That's 26 years. 26 years, guys. And so that's why you can't put, I get my light. You can't grow enough above ground to add to your organic matter. It all needs to be down below ground. That's why these cover cropping is taking off so huge and they're working so well. Just because you go to no-till, it's still going to take a lot of years. You need to fill the gap. So if you have another 30-inch row over here, you got this whole gap that you need to fill up with roots. Before the crop and after the crop also extend that season of roots. If you want to build organic matter, plain and simple, if you no-till, add more roots. That will build your organic matter, or bring in cattle with the manure. That will bring in organic matter. And so I think it's as simple as that, guys. Not so short, but short, sweet, simple. You guys got questions, comments, leave them below. Thank you for watching.